Number 3 from quiz 7172 says, find all exact solutions to the equation 2 cosine of 5 theta plus the square root of 3 equals 0. Ooh, remember doing that? So first of all, remember there's two types of equations they can give you. They can give you one that says find all solutions, which is like what this one says, or they can say find all solutions between like 0 and 2 pi or 0 and 360. That's when you only give me the answers that go between that. What do you do first on this? Right, so cosine of 5 theta, I could just subtract the square root of 3 and divide by 2. And without a calculator, right, if this is on without a calculator, that means this should be something from my unit circle, right? With the calculator, they could give you something where you have to use the button on your calculator and solve it because it could be ugly. But if this was on the no calculator part tomorrow, then this is going to be something from your calculator that you have to do. So, step 1, you need to figure out, forget about the 5 for a minute, where does cosine equal negative square root of 3 over 2? Cosine is x. Here, is that right? So that would mean, I like to say 5 theta equals 5 pi 6. And to show all my answers, what do? I put plus 2 pi n, where n is an integer, but we kind of just know that now, right? Is there another place where cosine is negative square root of 3 over 2? Right on there, right? So I can also say 5 theta equals 7 pi 6 plus 2 pi n. What do I do with that 5? Yeah, I'm trying to get theta by itself, so I have to divide this whole answer by 5, right? It means normally there's 2 answers. This really means there's 10 answers for what's up there, but I don't want you to write all 10 answers. I just want you to divide by 5 here. And so we would say theta equals 7 pi over 30 plus 2 pi n over 5, or you could put 2 pi fifths and then the n out there, doesn't matter. Really ugly answers, but the process is that we're looking for here. This one actually works out, because when we divide by 5, those 5s are just going to cancel. So this actually just changes to pi 6. Do you agree with me on that? Because 5 pi over 30 plus 2 pi fifths n. What proofs did I give you on the review?
Not too bad. So probably 4.
Number 1 and 2 on page 496. 496. 1 and 2. That's the only ones I gave you. No. 5 and 4. What was the number 4? So here's the thing with proofs that are so bad. Well, actually, you tell me what's bad about proofs. Knowing where to start, right? What are the possibilities we can do?
What are the things? Saying the change signs and cosines, find common denominator.
Yeah, so change signs and cosines would be like my last step. But definitely you want to look for common denominators. There's no fractions in this, so that kind of doesn't work. So hey, look, strategies. What else could we do? Factoring, right? If you can see like perfect squares, especially like a perfect square minus a perfect square, that'll always factor. So like, remember that like a plus b and a minus b equals a squared minus b squared. So if they give you something like this, probably maybe they want you to factor it. Look for identities, especially those Pythagorean identities. Yeah, have you forgotten those already? Those might be some you need to study. Sine squared plus cosine squared equals 1. And 1 plus tangent squared equals secant squared. I'm going to look those up. What else could we do? Distribute, multiply. I'm just gonna put algebra. Change the sines and cosines. Not always the best choice. So like try other stuff first. What? Oh. Also, like, remember the rules of algebra in terms of don't break math balls, don't cross out fractions, don't separate things that can't be separated. Oh, what else? I'm going to throw one more in here. Remember that reverse common denominator where you can take a fraction and break it up into two parts? So, like, I'm going to put, like, undoing a common denominator. Looking at your test right here in front of me, number 4 is, of the ones I gave you, is the most similar. It's not the exact question, but there's definitely powers in the ones on there. What do you think is a good strategy to do on number 4 based on how it's written? Yeah, like work this out to the second power, and here's where you got to remember your algebra. This does not just equal tangent squared plus cotangent squared, right? Like you have to FOIL it out. Two of them, so it would equal tangent squared plus tangent times cotangent plus tangent times cotangent, which I'm going to say is 2 tangent times cotangent plus cotangent squared. You agree with that? Also remember that you're supposed to just work with one side. So I picked to work with this side, and I'm going to try to turn it into this side. So then it becomes, what can I do? And for me, look right here. What's tangent times cotangent going to be? Just 1, right? Because they cancel each other out. So I could say tangent squared plus 2, because that just equals 1, plus cotangent squared equals secant squared x cosecant squared x. Oh. Should we have done sines and cosines? Yeah, like look at the other side. Here's how this is why I'm thinking of this now, which we can still do it now. This is addition. I can't think of a way that I'm going to be able to substitute in for tangent and cotangent that's going to make that addition go away. And over here, there's no addition. And these, like this is like 1 over cosine squared and 1 over sine squared. So I multiplied, I simplified what I could, and now I'm going to say let's change them into fractions. Let's change them into sines and cosines and get a common denominator and see what happens. You said tangent squared and cotangent squared canceled out?
Well, tangent squared equals secant squared x minus 1. Cotangent equals secant squared minus 1.
Oh, does that work? Let's try it. Okay.
Plus cosecant, but then I somehow changed this to sines and cosines, but
Okay. I'm gonna try before I do common denominator. Let's try Jake's way. Tangent squared equals secant squared minus 1. Is that true? Is 1 plus tangent. So secant squared minus 1 equals that. Plus 2. Oh my gosh, I think this is going to work. Cotangent squared is cosecant squared minus 1.
Yep.
Jake, you just saved me a whole bunch of work. Getting a common denominator would have worked too, but it would have been way more work. So that's what that aha moment is. Like I hope you have that on the test tomorrow. You see it and it works and it's easy. But the thing is, there's more than one way to do these proofs. As long as you're not breaking any rules, and as long as you are using correct identities, you can get there a much different way. But this works really well now because -1 plus 2 minus 1 is just 0, so those all cancel out. Oh no, what happens? We're not there yet. I thought this was just the answer. It's plus cosecant, right? Oh, we're so close. But we're still going to get there. We still got to get a common denominator now, right? Dang it. I thought it was like it's super easy now. So this would be 1 over cosine squared plus 1 over sine squared, right? We're almost there. My advice is do the other part of the test and come back to it. But common denominator would be cosecant squared times sine squared. And you just got to flip them around, right? So this would become sine squared plus cosine squared. So that would go over there and that would go over there. And I would get 1 over cosine squared x sine squared x equals secant squared x cosecant squared x secant squared x cosecant squared x equals secant squared x cosecant squared x. That's ridiculous. Finally, right? What about what if I gave you this one? I think we did one like that on our homework at one point. Not on your review. I just picked it. So the fourth kind of throws you, right? Like it's something that's not that identity, which tells me that's the side we should work with. What if you had x to the fourth minus y to the fourth? Could you do anything with that? Can you factor that? Is that still the difference of two squares? It's just to the fourth power? So let's factor this. What does sine to the fourth r factor into? And cosine to the fourth would be cosine squared plus minus. We do, but looking at what's over here, we don't even need to factor the other difference of squares, right? Like we want this, we have this. How do I get rid of this? If I just equal 1, that's a Pythagorean identity. So that's it. That's your proof. It'd be awesome if your homework, if your test was that easy tomorrow. Well, maybe you will now. Alright, are there other questions on the review you want to look at? I don't know, do you think you guys are going to be done testing by tomorrow? Because he doesn't know how long the test is.
Honestly, I didn't either.
I forgot.
Yeah, I thought I was done the test. I'm still kind of confused with what's happening. No, no. You got this.
I'm a terrible test taker. It sucks.
Oh my gosh.
Yeah, that's it. Like I told Mr. Rose, I'm not worried about whether or not I passed the econ test. There's only 4 of us in there, and what I'm worried about is that all the other 3 kids are gonna get like 3s or 4s or 5s, and then I'm gonna get like a 4th. He's gonna be like that scanner, and
Who's in the class?
it's me, Mason, Colton, and Cora.
Okay.
Yeah.
Guys, what about the solving equation ones I gave you on And the directions say find the solution of the equation that are in the interval from 0 to 2 pi. So first of all, remember when you're solving equations, you don't want to divide by a trig function, because if you divide by a trig function, you're going to lose out on this answer. So you never want to divide. Good strategy is get it equal to 0 and try to factor. So on this one, you would want to subtract cosine over, and then you see that we could factor a cosine out in front. And we'd have cotangent squared x minus 1 equals 0. It is. The good thing is with an equation, if you don't even replace it with an identity, it'll still work out the same way. It's whatever you want to do. If you want to change it to cosecant, or you want to just leave it cotangent squared minus 1. It doesn't matter. But if you get it to factoring equaling to 0, do you remember you can separate it now? So we can say, like, where does cosine equal 0? I'm going to leave it like this just because I want to show you, like, solving this, but it would work with, that equals negative cosecant, is that true? 1 plus cotangent equals cosecant, isn't that true? So cotangent minus 1, that doesn't equal anything, does it? That doesn't equal cosecant. You with me on that? So be careful, right? I call this my brain work. I write it down sometimes. I write down the theorem and see if it matches up. So let's leave it as cotangent squared. And is it okay if I just add the 1 to the other side and say that? Okay. So if it said find all solutions, you would find your answers and do the plus 2 pi in. This one says find between 0 and 2 pi. It might say find between 0 and 360. That just means you give the degree answer, so just pay attention to it. So where between 0 and 2 pi does cosine equal 0? And cosine is the x, so pi halves, 3 pi halves. Yes? What about this? Where does cotangent squared equal 1? Could I get rid of this squared? What would I do to get rid of that squared? Square root it. And what do I have to remember that I do when I take the square root of both sides of the equation? That's plus or minus 1. So normally when I do this, I get 2 answers. But if I have plus or minus, where does cotangent equal plus or minus 1? How many answers am I going to have? You're going to have 4, because every quadrant, it's either positive or negative 1. So just be aware of that, all right? It's easy to forget your plus or minus. Cotangent or tangent equaling 1, it's my favorite angle. What angle is it? It's all the force, right? So it's just pi force, 3 pi force, 5 pi force, and 7 pi force. I like when it's plus or minus because I don't have to figure out which quadrant it is. I just figure out the angle and it's all of those, right? If it would have worked out to be pi 6, it would be all the 6. Or if it would have been the thirds, it would have been all the thirds because you just pick them on each quadrant. So be prepared for that. Then you would do the plus 2 pi in on those. They're doing a quadratic formula. It does sound terrible. Tomorrow, the no calculator part's supposed to only take 20 minutes. I'd like to do like the last test where like I gave you like the first page of the calculator part so we can kind of fit it in 2 days. But if half our class is gone tomorrow, if they're not back from the testing, then I'll probably just do the no calculator only, and then we'll go from there because you guys are 50 behind if you learn from it. So.
Well, if we're not here tomorrow, then I can come in second part.
Well, but Bobby and Courtney both leave after this hour, so it's. But, yeah, so we'll see. I don't know what test it is, so I don't know how long it'll take. But we're definitely doing the no calculator part. So that stuff that I told you, study the quiz I just gave back to you, proof, or the first quiz and the last quiz. Those would be the 2 I would say that you should study tonight. And make sure you just know your identities, because if we do the calculator part of the test, that's where the sum and difference, the double angle and the half angles are going to come in more than the no calculator part. It's only 6 questions tomorrow, so one of them first. So
it's like the stuff you just did, approve, and
equations. Yeah. So like the quiz 1, that's your proof and your equations, and then quiz 6, that's your other problems. So if you know your restricted domains and ranges, you should be good on this first part.